Hello everyone. In this video, I will explain the local optimization concept. And in this phase, the first optimization is about elimination of common sub-expressions. You can refer to the sample code given on the screen, wherein we can see that there is a repeated execution of the statement B plus C. And we will try to eliminate this repeated execution of the statement B plus C. Along with this, we will also try to understand copy propagation and dead code elimination. So the first step to eliminate the common sub-expression is to convert the given code into three address code, which you can see on the screen. That is, we have started with using the temporaries. So T1 equal to B plus C. Then we can write A equal to T1, and so long we can continue with T2 and D. Since there is no else statement in the if, we can reverse this condition and make it more efficient. So if A is less than 10 is converted to A is greater than 10, and we can write it as go to 109. So if it is greater than 10, then it will not execute these instructions and it will directly jump to while loop. So starting of while loop is 109. Hence we write go to 109. After this, if the condition is true, that is uh, in the reverse form, if the condition is A less than 10, that is, if this condition is false, then we can execute these four instructions, wherein again B plus C is executed. After if there is a while statement which says D less than 20. So if D is less than 20, go to 111 and execute while loop. And if D is not less than 20, then go to 116 and exit. While loop is also reach back if in order to check the condition. So after incrementing the value of D, go to 109. So this is the while loop which is being executed multiple times as long as D is less than 20. Now, the first step is to convert this three address code into directed acyclic graph, that is DAG. For this, we can use the nodes B and C and operator as plus and assign the LHS variable name T1. So simple structure will be B, C plus, and then we can put it here T1. Now, wherever T1 is there, and if it is reused, then we can put those variables at T1. So A is also there, T2 is also there, D is also there, and also T4 and E. So all these variables as well as T7 and G. So all these variables will be at same place. Now, if you want to draw the DAG for A greater than 10, then you can take A 10 and you can take the condition greater and write here 109. So this is A greater than 10. And if you want to draw T5 E plus D, so you can take E, you can take D, you can add them, and you can write here T5. So all this will be at same level. Similarly, T7 equal to B plus C is already there. T8 equal to D plus 1, so you can take D, you can take 1, and you can take plus, and you can take T8, and you can take D. Okay, so this way the DAG is constructed. Now, how to optimize this three address code? So first optimization is to look for the labels which are multiple times referred. For example, the label T1 is referred by multiple names like A, like T2, like D, and like T4, and like E, and for the T7 as well as G. Okay. So this way, wherever all these variables are being used, we will try to optimize the code with the help of T1. So first step is to eliminate the code which is redundant in nature. So the code which is redundant in nature is being eliminated. Wherever we are writing B plus C will be simply removed from the three address code. Okay. So we will be reducing the three address code by removing these three instructions. Next, this is called as elimination of dead code. Okay, because this code, even if it is executed, will not create any effect. Now, second step is to perform the propagation of T1 across. This is called as copy propagation. So wherever we have used uh, the the variable T1 and its replica or its allies is being referred, then that allies will be replaced by T1. So D was equal to referred as D was referred as T2, but T2 was equal to T1. So replace that T2 by T1. So everywhere T1 will be replaced. Okay. And in this way, what you can observe is 101 is modified, 103 can be also modified with the help of copy propagation. 102 is also modified. This A can be also replaced by T1 because A is equal to T1 and the recently referred variable is T1. Okay. So this, if I write if A is greater than 10 and if I am referring A equal to T1 and value of T1 is not modified between these two instructions, then I can copy propagate and take the help of T1 to write the condition T1 greater than 10. This is possible as long as the values are not modified. Okay. This will also allow us to modify this E plus D statement. Refer the value of D, which is T1, refer the value of E, which is also T1. So now I can propagate the copy and I can write T1 plus T1. In this way, the code is optimized and as well as the copy propagation is also performed and the dead code is also eliminated. This particular video explains the concept of elimination of common sub expression. Then after eliminating the common sub expression, elimination of dead code, and after elimination of dead code, we can also perform the copy propagation. Hope you understood this. Thank you.